Sir Isaac Newton was a mathematician and physicist from the late 17th century to early 18th century, well known for his discoveries in mechanics, universal gravitation, calculus, and what we'll be focusing on today, his laws of motion. Newton had concluded that there were three different laws of motion.
Newton's first law states that if the net force on an object is zero, the object will remain or continue to move at a constant velocity. What this means is that if all the forces acting upon the object are balanced, the object's initial velocity will not be affected. An example of this law would be if my sister is standing at rest. The force of gravity pulling her down is matched by the opposite force, the normal force, at an equal magnitude. However, if there is a strong enough wind blowing towards her, those forces acting on her will become unbalanced, forcing her to tip over in the direction of the force of the wind that is pushing her.
Inertia is the resistance of any physical object to have any change in its velocity. Referring to the example of my sister, in order for the unbalanced force of the wind to tip her over, the force would have to be greater than her inertia. The greater the mass of the object, the greater its inertia, resulting in the need of a greater force to change the object's initial velocity. Newton's second law states that if the net force of an object is not equal to zero, then the object will accelerate in the direction of the net force. An example of this law would be if you were holding an ice cream cone, but then all of a sudden you squeezed too hard and broke the cone. The cone was acting as the normal force that balanced out with the force of gravity, so the ice cream scoop did not fall out. But if that normal force is no longer there, the net force in the ice cream scoop is now unbalanced by the force of gravity, forcing your ice cream to get covered in grass and dirt. Dirt Sunday, anyone? We can calculate the force of an object by using the formula mass times acceleration equals force. And we can also rearrange the formula to solve for the acceleration or the mass if given the proper information. The third and final law of motion states that every action force has a simultaneous, opposite and equal in magnitude, reaction force. Say you were angry and started punching or kicking the wall. The force you exert when punching against the wall will be matched with an equal force in magnitude, but towards you, not against the wall, itself. One final concept to be aware of is Newton's cradle. You may have seen one of these before in an office. Have you ever thought about why only the end balls move? It is because the force and energy transfer that passes through each metal ball in between the end balls. If you pull back on the end ball, once that force is exerted on the ball in front of it, that ball will immediately transfer the energy to the one in front of it because it has nowhere else to go. Once this motion energy passes through each ball, it will reach the end ball, which you will see move because it has nowhere else to transfer it to, until it comes back.